Okay, we have 35. That's good. Draw. Okay. So this is the question in web design. Some of you asked me, told me that you can do it, but you don't really understand. So we are going to go over this one. So the gravitational force exerted on a solid object is 5.1. Let me pin myself. Tak macam pelik pula. Okay. As measured when the object is suspended from a spring scale, as in figure A. So this is the spring scale. So at first, it is 5.1 Newton, right? It is 5.1 Newton. What is the scale detecting? It is detecting this mg, which is mg is equal to 5.1 Newton. The way that this works is that the scale and the object is in equilibrium, which is how it is measuring the object. When we have mg, we also have r. No, it's not r actually, it's F apparent, or the F that is measured by the scale. Sometimes this F apparent is equal to mg, sometimes it is smaller, sometimes it is bigger, depending on the situation. That is what the scale is detecting. Dia bukan detect, because the scale is, the object is not moving upwards or downwards. There's no acceleration going up, there's no acceleration going down, which means that the object is in equilibrium, which means that there is an F apparent detected by the scale, right? Okay, I know it's a confusing concept, but just bear with me. The scale detects F apparent. All right, so now let's move on to the figure B. We know that this guy has an mg of 5.1 Newton. The scale detects 3.58, which means that F apparent is equal to 3.58 Newton. But this guy's mg is 5.1. They are in equilibrium because why? Object is not moving upwards, it's not accelerating upwards, it's not accelerating downwards. So you know that they should be in equilibrium. Everything should be equal to 0. So how do we find out what is the buoyant force acting on this object that causes the F apparent to be 3.58? Okay, so F equilibrium means F net in the Y is equal to 0, which means that F actual, which is the weight, I need more space. Sekejap, silap. Okay, hopefully that is more, I can write better. Okay, so it means that F actual going down. So F actual is going down, right? Silap. Sorry. Okay. Okay. Cooperate with me, please. Okay. Equals to minus F actual going down plus F apparent going up, and F buoyant is typically going up, right? So F buoyant. So everything should be equal to 0. Because why? The object is not accelerating upwards, it's not accelerating downwards. So now, you know that F actual is minus 5.1. Our F apparent is 3.58. Our FB is, we don't know. So this is all equal to 0, and FB is equal to 1. If we are using my question, right? I know you guys have different values. It's equal to 1.52 newtons. Okay. And then buoyant force, what is buoyant force? Buoyant force is always the weight of the water, okay, weight of the water displaced by the object, right? If we are talking about the weight of the water, which means that we need to use rho, which is rho water, not rho object, it's rho water, the density of the water, which is rho water times gravity times volume of object. Since we know what FB is, which is 1.52, we know what raw water is, it is 1000 kilogram per meter cube. We know what G is, 9.81. We can solve for V. When we solve for V, we already know what is the mass from this actual guy, right? So F actual is equal to mg. It is equal to 5.1. I solve for mass. What is it? I don't know. I haven't calculated it yet. I know what my V is, and rho object is equal to mass over V. So that is how you find the density of the object. Okay, the thing here is that I think is confusing for students is F apparent, the concept of F apparent. Whenever you have a scale, the scale is always measuring your F apparent. Remember when we learned last semester when you were in a lift and you were either going up or going down, the F apparent, the scale detected different weights. The scale was measuring F apparent, which is the same case in this example. No, not in this example, in this problem. Your F actual is not necessarily measured by the scale. The scale measures F apparent. If there is an external force acting on the object, such as in this case, the buoyant force, the F apparent becomes smaller, or it could also become larger. So always scale detects F apparent, okay? And the scale is in equilibrium with the object. So F net is equal to 0. Something is acting on it. You have to figure out why. I hope that was clear. It's a pretty confusing concept, but I hope I made it clear for you guys. Okay, so this one. If you have questions, you can interrupt me. Okay, moving on to this problem. A 1 kilogram beaker containing 1.95 kilogram of oil. The density is given. Rests on a scale. So we have two scales here. Again, we're talking about F apparent. We have two scales here. One is at the top scale. This guy is called the bottom scale. You've seen this. If you haven't, then you have not gone out of your house very often, because this is a very common item. Okay, it's suspended from a spring scale, which is our top, and is completely submerged in the oil. See figure below. Okay, find the equilibrium readings on both scales, of both scales. The word equilibrium here is what I mentioned earlier. The scale is always in equilibrium with the object. You just have to know what is the force acting that causes the F apparent to be smaller or bigger. Okay, so let's start with this one. Untuk orang yang dah tahu, I'm sorry, I just need to repeat this for orang yang tak tahu. So bear with me, please. Okay. So what was it? Let's start with the top scale. Okay, so 1.95 block of iron is suspended. Okay, so the F actual here is, F actual is 1.95 times 9.81, which will give you, I don't know, I haven't calculated yet. What is the top scale detecting? What is the top scale detecting? It is detecting mg. There's also FB acting on it. What else? The top scale detects downward force. What is acting on the object right now? Confused dah bila cerita pasal ni? Okay. Okay, let me start again. Okay, so let's start with the top scale. The top scale, kita kena rasa benda yang berat, right? Benda yang tarik dia. Okay, so what is pulling it down? What is pulling it down? So we know we have mg, but our mg is ada buoyant force acting on it as well, right? So there is FB going up. So am I detecting mg or am I detecting something lighter right now? Am I detecting the actual weight or am I detecting something lighter? Can anyone answer me, please? Everyone's confused? Try lah. Come on,
Something
guys.
lighter.
Something lighter. Why?
Because the F buoyant.
Because of the F buoyant. So the F buoyant is pushing.
Yes,
Here are the
it supports
scales.
some of the weight.
Yes, dia ambil some of the weight. So apa yang tarik the scale is less, right? So here, the top scale, whoops, top scale detects F net that is going down. So that is equal to, what is it? Actually, I have not calculated it yet. So mg minus fb. So that is what it is detecting. What about bottom scale? Okay, what is the bottom scale detecting? What is the bottom
beaker.
scale detecting? So we have the beaker, right? The one
Oil.
beaker. Tadi kita top scale dia tak detect beaker because beaker was not attached to it. The top scale was only attached to the block of iron and some buoyant force dia acting on the iron. Because it's attached to the iron, dia akan rasa jugalah the buoyant force. The bottom scale, however, detects the beaker because the beaker is on top of it. So dia bersentuh, so it detects that. That's the first one. Second one, detects the weight of the oil. Right? Number three, it detects FB but going down. Why? This part, why does that happen? Yang ni kita tahu, ni senang je. Kalau saya ada beaker of oil, I put it on the scale. Oh, the scale is detecting the beaker and also whatever that is inside the beaker, right? Kalau oil, oil lah. Kalau water, water. But now, when I put the iron inside that beaker of oil, I see an increase in the scale. Maksudnya it's detecting something, but it's not detecting Mg, it's detecting something else. Why is it detecting FB? Ramai dah siap ni, macam mana korang buat tu? Okay, so remember I told you when your object is not accelerating upwards or not accelerating downwards, what's going on?
Equilibrium.
In equilibrium, right?
Equilibrium.
Yeah, so F net is equal to 0. If we know that something is going up on the iron block, there is definitely something going down on the iron block as well. So this something that is going down, which is FB, is detected by the bottom scale. Okay, kejap. Kita padam balik. Memang benda ni memang confusing. So just to try our best, okay? So we detect the beaker, we detect the weight of the oil, and since there is FB acting on the block because of the oil, there is a equal force, which is equal to FB. There's an equal force acting on the iron block as well, pushing it so that the iron block does not shoot up. Kalau ada FB je acting on it, the iron block would like fly up and that would be like crazy, right? Like kita letak dalam oil je dia meletup, letak dalam water je meletup because it's accelerating upwards. That does not happen in real life, right? Which means that there is another force acting on the iron block that is equal to FB. The bottom scale detects this downward force just as it detects the beaker, just as it detects the oil. Okay, so dia detect semua yang ke bawah dia akan detect. So apa yang ke bawah is an equal value, a force that is equal to FB acting up on the iron. So these are the three things that it detects. This is what the bottom scale detects. Okay, senang je nak cari FB kan? Nak fahamkan macam mana dapat FB tu. Okay, so that is your bottom scale. Your top scale, again, I'm going to repeat myself. The top scale detects apa? The actual weight. Kalau kita, okay, bayangkan top scale tu dia pegang iron block je. Apa yang dia detect? Dia detect mg sahaja. But when kita letak dalam air, dia akan jadi ringan kan? Just like we enter the water, we become
Lighter.
lagi ringan lah. Bila kita masuk air, kita rasa badan kita jadi ringan, right? Sama juga, scale detects the iron block, mg. Letak dalam oil, dia jadi ringan. Apa yang berlaku? Buoyant force acting on it. So the scale only detects mg minus fb. Okay. Dia tak terganggu oleh beaker, dia terganggu oleh buoyant force sahaja. I hope. Is everyone okay?
Doktor,
Yeah.
kalau yang FB ke bawah tu, kalau saya buat MG tolak FB tak boleh?
Yang ni, bottom scale.
Bottom scale.
Awak dapat
Saya
jawapan
bayangkan salah juga.
habis tu.
Saya bayangkan macam kalau MG ni ke bawah, lepas tu ada FB ke atas. Lepas tu benda tu kan dia stay tengah-tengah sebab MG tu dia dah ada support dengan FB, dia masih ada sikit kan kat bawah tu. Maksudnya ada baki lagi dia berat dekat bawah kan. Dia ke bawah lagi force dia kan. Kenapa yang tu kita tak kira dekat bottom scale?
Kenapa saya stuck Oh okay, saya dah stuck dah. Awak cakap bottom
Saya
scale tu
kira
dia
macam tu.
detect mg minus fb. Tu awak punya teori lah macam tu. Macam tu ke?
Tengah fikir tengah fikir
Sekejap, internet
tak
saya tak
faham.
okey ke? Saya setengah stuck Korang nampak saya stuck tak?
Stuck
Okey.
sikit.
Sikit-sikit lah.
Tapi suara okey kan?
Okay.
Alright. Okay, baik.
Saya keliru kat situ.
Boleh tak awak cerita lagi sekali apa yang awak faham tadi? mg.
Yang saya faham, MG force dia ke bawah. Bila dia masuk dalam air tu, dia ada FB yang kat atas kan. Tapi still bila top scale boleh detect MG dia ke bawah, maksudnya MG tu dia minus dengan FB, dia masih ada force ke bawah sikit kan. Jadi dia lighter lah force dia. Force yang ke bawah tu.
Force yang
Kan.
lighter.
Sebab dia dah minus dengan force yang ke atas oleh FB tu.
Kita kena masuk lab ni sebab awak tak nampak. Okay. Kalau awak letak air atas, a beaker of water atas scale kan, awak gantung je something, awak jangan, kalau awak letak atas beaker, macam nak cakap okay, saya lukis lah. Cuma nak cakap ni. Okay, so sekarang ni benda ni tak bersentuh kan. Kalau saya letak ball saya betul-betul atas scale tu, yes, dia detect mg. Tapi sekarang ni benda ni tergantung tau. Maksudnya dia tak boleh detect mg. Dia hanya akan detect the extra push by FB sahaja. Mg tu dia tak boleh detect pun sebab dia tak bersentuh. Benda ni pegang mg. So dia tak rasa mg tu sebenarnya.
Okay.
Macam awak angkat budak tapi awak letak budak tu atas orang lain. Orang lain tu rasa weight of budak tu tak sebab awak pegang dia kan. Faham tak? Awak pegang bola, okay kita cakap budak lah. Awak pegang bola tu 1 kg. Awak letak tangan awak atas tangan kawan awak. Tapi awak tahan bola tu. Kawan awak rasa tak bola tu?
Tak.
Kan? Awak yang pegang bola tu kan. Sekarang ni awak tu yang awak pegang bola tu is the top scale. Dia pegang mg tu. So ni kawan awak tak rasa pun mg tu. Sebab tak bersentuh pun. Weight tu tak rasa kat dia. Dia hanya rasa force. Buoyant force je. Sebab buoyant force tu datang daripada oil. Sebab tu dia boleh rasa.
Okay, dah dapat dah.
Dapat dah?
Okay.
Alright.
Thank you, Doktor.
Okay, welcome. Okay, any other questions before we start chapter 14? Okay, Sekejap, let me see the participants. Saya nak kena check ni siapa yang selalu tak datang ni. Oh, Redha dah ada. Hai Redha. Lambat awak hari ni. Sekejap participants. Tak pandai pula nak pakai mendalah ni. Okay, it's here. Oh, kita ada 37. We are missing 2. Siapa tu? Siapa yang tak ada sekarang? Hikmah dah ada. Aina Nabila, are you here? No, you are not. Siapa lagi seorang tak ada? Perasan tak? Nurhan ada sini tak? Nurhan.
Ada Miss. Ada ke?
Hai Nurhan, saja nak cek awak. Siapa lagi tak ada? Saya tak perasan. Susahlah nak cek. Okay, tak apalah. Nantilah saya cek balik semula. Okay, so sekarang ni. Kalau korang ada masalah dari segi gadget, like you don't have a laptop to attend class, you can tell me. Okay, kita akan cuba usahakan something. Saya tak naklah student saya tak dapat nak follow class because of tak ada laptop, tak ada gadget. Okay. Kalau awak tahu kawan-kawan awak dalam kelas ni yang ada masalah tu, let me know. Kalau diorang malu, awak boleh tolong cakapkan untuk diorang. Saya tak nak ada orang ketinggalan because of gadgets hopefully, and that's why I record my classes so that siapa yang ketinggalan boleh refer. The aim here is not to punish you guys. I want you guys to learn. Okay, kita nak sama-sama pass, nak sama-sama cemerlang. Okay. Right, so let's start with chapter 14. Oh my god, what happened here?
Doktor.
Yep.
Macam dalam kita punya learning outcome tu, chapter 13 kan ada hydrodynamic kan?
Ada hydrodynamic, tapi tak masuk. Kita orang, bidang fizik cakap hydrodynamic ni dia tak masuk, macam mana cakap? Dia tak masuk dalam rancangan pengajaran kita orang. Siapa conteng saya punya ni Ada orang kot conteng saya punya Zoom. Hydrodynamic tak masuk untuk exam pun tak masuk. So kita hanya cover sampai hydrostatic, which is something which is in equilibrium sahaja. Okay?
Okay, terima kasih.
Oh, before I forget. So we have quiz on week 7. Quiz. Week 7. What is it covered? What does it cover? Chapter 13 and chapter 14. Where is it done? On WebAssign. Is it unique to your class? No. Selaras semua kelas kita akan buat sama-sama. Everyone will do this quiz together. Everyone will get the same question but different values lah, of course, because WebAssign. What I can say for now, because we have not done the questions yet, but we are aiming to do conceptual questions. Conceptual plus kira-kira sikit lah, macam biasalah. Kira-kira tu biasa dah kan, conceptual pun ada juga. I believe it will be MCQ, but I'm not sure yet. I will get back to you on that. But chapter 13 and 14 ni confirm Week 7 confirm, chapter 13, 14 confirm, WebAssign confirm. Format soalan tak confirm lagi. But as usual, you won't get the same questions as your friend. Memang akan lain. So, tak boleh tiru lah. So kena faham lah, okay? If you have trouble to understand the content, you can always look back at my YouTube videos. You can always ask me. We can have a private session on Zoom if you need it, okay? So just let me know. Okay, so chapter 14, we are doing heat. Thermal expansion, heat transfer, heat energy. Chapter 14 is quite lengthy. I'm targeting around 2 weeks for this chapter. Chapter 13 kita buat seminggu je. Chapter 14 we are aiming for 2 weeks. Okay, so let's start. Hello, nak boleh tak bergerak? Okay, so temperature. Temperature is the property that determines whether or not the object is in thermal equilibrium with other objects. We are talking about equilibrium again. Tadi kita cakap pasal force. Now we are talking about temperature. Temperature equilibrium. Okay, what is that? What on earth is temperature equilibrium, right? So a quantity that shows the degree of hotness or coldness of an object is called temperature. You know this already. Makin tinggi, makin panas. Makin kurang, makin sejuk. It's a base quantity. It's not a derived quantity. If you guys still remember, we learned about base quantities in semester 1, such as meter, which is length, temperature is one of it. Apa entah lagi, I forgot. Contoh derived quantities is like velocity, meter per second, acceleration, meter per second squared, benda yang ada gabungan meter dengan time, right? Length with time. So that is a derived quantity. If it is made out of a single quantity, it is called a base quantity. So tu je cara nak ingat dia. Yes, okay, moving on. So transfer of energy from an object or a system to another as a result of temperature difference. Let's say this object number 1, so this is object number 1, has a high temperature. Let's say it's 100 degrees Celsius. And this is your hand. Your hand is typically what? 37 degrees Celsius, assuming that you are not having a fever, right? You touch a 100 degrees object, what happens? You feel the hotness, you feel the high temperature, you feel sakit lah, right? It's painful to touch something that is very high temperature. What happens? Your hand absorbs this heat. So heat transfer occurs from this 100 degrees Celsius to your hand. That is how your hand melecur, because the heat is too much for your skin, for your body. So heat transfer occurs, your hand experiences high temperature, maybe possibly naik ke 40, tapi kat tangan je lah, melecur. Okay, heat transfer occurs. Another example is you have, this is an ice cube and this is a regular water, tapi takkan nak jadi cube pula kan. Okay, abaikan example ni, pelik pula. Let's say something that is very high temperature lah. So this is an iron that is at 50 degrees Celsius. And you have another iron that you took out from the fridge, from the freezer. This is also an iron. 0 degrees Celsius. What happens to both of these iron? This guy transfers the heat. Why? Because they are not in temperature equilibrium. They have differences. When they have differences, diorang nak gaduh. Kita tak ada gaduh pun. So ada heat transfer. Heat transfer occurs. What happens? This guy increases in temperature. This guy decreases in temperature. Sampai they reach a similar temperature. Let's say iron ni dah habis kasih heat. Iron lagi seorang ni pun dah habis terima heat. Their final temperature is, let's say, 33. Both of them are 33. What happens then? Tak ada heat transfer dah, they are in equilibrium. So when they are of similar temperature, there is no heat transfer. When they are not in equilibrium, heat transfer occurs. Okay, it's a pretty simple concept. Temperature difference, heat transfer. Same temperature, equilibrium. Okay. So now we are learning about Xero's law of thermodynamics. What does it mean? What is this law? If objects A and B are separately in thermal equilibrium with a third object C. Okay, kita tengok dulu gambar ni. So A ni dia 50 degrees Celsius. C pun 50 degrees Celsius. So they are in thermal equilibrium. Silap, ni A and B. Dia cakap A ni thermal equilibrium with C and B ni pun thermal equilibrium with C. So B is in thermal equilibrium with C, which means that A and B are also in thermal equilibrium. Okay, kenapa kita bersusah payah nak buat pasal law ni? Kenapa tak measure je? Sometimes a measuring device, a temperature measuring device is not available. So this is the use of the zeroth law of thermodynamics lah. Okay, contohnya lah, awak rasa dahi awak kan? Okay, it's just a regular temperature. It feels the same as my hand. Maksudnya thermal equilibrium lah, tak rasa apa-apa. Rasa biasa je lah. When you are having a fever, your temperature increases. Your friend comes and touches your hand, touches your head. Rasa panas sikit, which means that heat transfer is happening from your body to your friend's hand. So kat situ kita tahu, oh, this I am not in thermal equilibrium with my friend. I'm having a fever. That is the concept here. Kita boleh, kalau kita rasa sama temperature je, okay, my right hand and my left hand is in thermal equilibrium with each other. When I'm touching this calculator, which is slightly colder, my hand is not in thermal equilibrium with this calculator, which means that this guy should have a lower temperature. So this is what the 0th law of thermodynamics is telling you. Kita rasa thermal equilibrium ke tak? Kalau thermal equilibrium, kalau saya thermal equilibrium dengan tangan saya thermal equilibrium dengan kawan saya, maksudnya tangan ni pun thermal equilibrium with my friend. That makes sense. Okay. Right. So here is your conversion temperature scales. You have to know this, kena memorize. We typically use Celsius, but we can convert Celsius to Kelvin. We can also convert Celsius to Fahrenheit. Let's say I want to know what is 20 degrees in Kelvin. What is 20 degrees Celsius in Kelvin? So I use this equation, 20 over 100 equals to Kelvin minus 273 over 100. Cancels out, 100 with 100 cancels out. So here K is equal to 20 plus 273. That is your temperature in Kelvin. Pretty easy, you just have to know the equation. Okay, I believe this question is also on your, this equation. I'm sorry. I believe this is asked on your rep assignment for chapter 14. So you need to know this. Okay, so measuring device for temperature. First one that you are most familiar with is the thermometer. You've seen this since primary school, right? Dah pakai dalam lab, dalam high school kot. Okay, so you guys were reminded, do not break the thermometer. There's mercury inside, it's very dangerous, blah, blah, blah. So you've done it, you've used it and you've broken the thermometer, I know. Okay, because I done the same. Okay, so next one, thermistor, a type of resistor whose resistance is dependent on temperature. So the resistance, kita selalu tahu, oh, you guys have not seen the resistor yet. How do I explain this? You guys have not seen it. If you guys have seen it, a resistor looks like, this is not the regular one. So this is not the regular resistor. Selalunya regular resistor looks like this. And ada macam jalur-jalur tu. That is a resistor yang tak berubah with temperature. But this is a special kind of resistor over here, which changes its resistance value with the temperature. If you can look at this equation, you start with the initial resistor value, which is, let's say it's a 10 ohm resistor. With an increase in temperature, here, tengok kat sini, this is the original temperature. Let's say your initial temperature was 20 degrees Celsius. And then you heat up the resistor, I don't know why, but you decided to heat up the resistor to 30. Right now, your change in temperature is 30 minus 20, which is 10. So there is a value for alpha. 10 times alpha plus 1 times 10 will give you something that is greater than 10, which means that, greater than 10, which means that if you increase the temperature, the resistor value increases. It's a pretty neat concept. It depends on the application that you want to use. Contoh apa yang pakai? Saya tak ingat lah. You guys can Google this. It's pretty easy. Okay, thermocouple. Do I want to explain this? It's an electrical device consisting of two dissimilar electrical conductors. Here you have the first one. This is your first reference junction. This is your hot junction. This guy measures the temperature. This junction detects the temperature of the object. This is your reference point. They compare between these two to detect when there is a difference of temperature between the two junctions. There is voltage over here, and that is how the thermocouple works. Of course, this is something that you can Google easily, just like exposing you guys to the different types of measuring device. So this is famous this year, thermal camera, famous this year and last year due to COVID. You use a thermal camera to detect your temperature, just shoot, detects infrared radiation. What is infrared radiation? It is something that you can't see. What? Okay, right now you are looking at me, you are looking at the laptop. What are you seeing? You are seeing visible radiation. It's called visible radiation. Visible radiation means that you can see the colors. Red, blue, green are within the visible radiation spectrum. Infrared is something that you can't see. Your eyes cannot see unless you use a device. This device detects an unknown, this device detects the wavelength range that your eyes cannot see. Visible is from 300 to 700 nanometer. This is what your eyes can see. Beyond this, your eyes cannot see, so you need a device over here. Okay, so I think it's from 900 to 1,500. So this is the range that you can't see. So that is infrared radiation. This is visible. Infrared. How do you? Infrared. Do you need to know this? No, not really. I'm just telling you as part of like general knowledge. Okay, moving on. Thermal expansion. Oh, other classes, they were assigned to like investigate what are the different types of measuring devices. Do you want to do that? Saya rasa kita buat benda lain lah. Macam tak best pula benda tu. Tu korang Google sendiri je lah. Let's find a more interesting topic. So moving on, thermal expansion. After completing this chapter, you should be able to explain expansion process, define linear, area, and volume, expansion, and solve problems related to expansion of materials. What is thermal expansion? Thermal expansion of an object is the consequence of a change in average separation, blah, blah, blah. Okay, I don't like to read those things. What you need to know is you have an iron. When you heat it up, it expands, right? What happens? The iron takes up energy. What happens to the energy? The energy, mula-mula kita ada iron, atom dalam iron ni macam ni je lah kan, dia vibrate sikit-sikit je lah. When you supply energy, they vibrate more vigorously. What happens now? So they vibrate, okay tengok gambar ni lah. They vibrate more vigorously. Lagi macam, lagi tak keruan lah orang kata. Mula-mula diorang duduk diam je. Tu saya kasih Pepsi. Pepsi kan banyak gula kan. So this, you can assume it like heat energy. They absorb this energy, becomes hyper because of the extra sugar. What happens? They vibrate rigorously. When they vibrate rigorously, they need to have more space in between them. Sebab apa? Diorang berlanggar-langgar lah. So now I need more space, right? I need more space between these atoms because they are not behaving. What happens? The iron expands. That is thermal expansion. They take up the energy, they use it, bermenari-nari dalam tu, becomes bigger. Okay, that is what you need to understand. As temperature increases, the amplitude increases. The amplitude of vibration lah. Lagi tinggi temperature, lagi seronok dia menari macam tu. So lagi besar lah dia jadi. So this causes the overall object as a whole to expand. So the higher temperature, the more expansion you will see. Next. Linear expansion, kita ada linear, kita ada area, kita ada volume. Let's go with the linear expansion first. Let's take a look at this rod. Okay, so expansion of an object in one dimension. When we are talking about one dimension, let's say width, length, thickness. Okay, we are, oh kat sini ada, ya Allah, sorry, tak baca. When we are talking about one dimension, length, width, thickness, benda yang satu dimensi. We are going to talk about linear expansion. So what is linear expansion? This is the equation. The change in length over the initial temperature, over the initial length. Let me write it down. This is initial length. This is change in length is proportional to the change in temperature. Okay, what is change in length? Change in length is L new minus L original or L naught. Change in length is L final, L new minus the original length minus L naught. That is your change in length. What is change in temperature? Sama, T new or T. Siapa yang contoh saya Zoom ni ya? Tak padam-padam lagi. Okay, T naught. Okay, so that is the change in temperature. Now, proportional does not mean the equation. Proportionally a relationship saja. So the actual equation, we have an alpha here. Okay. Again, proportional is not an equation, it's just the relationship. So the alpha is the actual equation. So now if I were to expand this equation, right, delta L, L naught, alpha delta T. What is delta L? We know that delta L is L new. I'm just going to write L here minus L naught equals L naught alpha delta T. Now we have two L naughts. What happens? I'm just going to put it over there. So L equals to L naught plus L naught alpha delta T. Now I can factor out. Factor out. Is that the right word? Factor out L naught from that. So, okay, kalau saya pakai term-term math yang salah ni, betulkan je lah. So I'm not good at math. Okay. Right. So that becomes L naught 1 plus alpha delta T equals to L. So L, the final length, this is not the change in length. This is the final length equals to original length times 1 plus alpha delta T. Okay, sama tak? Yeah, sama. Okay. So that is your equation. That is how you get your equation. What is alpha? Alpha is the constant. It does not change for an object. It is called the coefficient of linear expansion. Okay, contohnya, kalau alpha untuk iron is 10, semua iron 10. Kalau alpha untuk copper is 12, semua copper is 12. It depends on the material. Okay. Macam, kita tengok tadi benda ni, I forgot. Tak apalah, korang tahulah kan, alpha is a constant but depends on the material. Okay, so moving on to area expansion. This is expansion of an object in 2 dimensions such as surface area. Surface area is in meter cube. Okay, so 2 dimension. Ada X, ada Y. For large thin plane, experimental results show that the fractional change in area over the initial area is proportional to the change in temperature. Sama macam length tadi. Just now we talked about delta L over L naught proportional to delta T. Now we have delta A over A naught proportional to delta T. Sama juga, this is just a relationship. The actual equation is equal to gamma delta T. Now again, we can solve for this, but you already know how to expand the equation. Senang je. So this is how you expand it. Area of an object is A, which is length squared, right? So we know that the equation for length is L naught 1 plus alpha delta T. So they are just using this again and saying, okay, let's just calculate area like this. Okay, so they use the same equation, square it. When you square this whole thing, you get this guy over here, A naught, you know, factor out lah. 1 plus 2 alpha delta T plus alpha squared delta T squared. Okay, since alpha is small, when you square it, it becomes extra small, right? When you have like 0.01, contohnya, you times it with 0.01, it becomes 0.001. Good. I don't know. Maybe. But it becomes really small. So here they cakap, okay, because alpha is small, when you have a square of it, it becomes super small that you can just ignore it, right? You can just ignore it. So this guy is like neglected, okay? So dia dah, kita tak nak adopt dia. So we neglect this person. We are left with just this part because this guy is super small. Okay, super small. So now we are left with this equation. And 2 alpha is actually gamma. Okay, so tadi we talked about gamma. Now, gamma is actually equal to 2 alpha. Okay, so now if they give you alpha in your question, to find gamma, you just multiply by 2 lah for areas. So gamma is 2 alpha. Alpha is just alpha. That's for a linear expansion. Typically, they will give you a alpha for the question. You need to decide whether it's area, its volume, or its length. Okay, so that's the tricky part there. The change in area is delta A equals to A naught gamma delta T. Okay, sama je macam equation kita tengok tadi. Delta, kenapa tadi tu? Oh, it's misbehaving. Okay, let's go. Okay, so gamma delta T. We have seen this earlier. Okay, so you have two equations, this guy over here or this guy. A new equals to A original times 1 plus gamma delta T. Gamma is 2 alpha. What time is it? Almost 1 hour. Kejap, 5 more minutes and then we'll take a break. Bear with me. Moving on to volume expansion, expansion of object in 3 dimensions. Tadi we were talking about X, which is for length. Now we are talking, and then area, we talked about XY, 2 dimension. Now it's XYZ. So X, Y, and Z. So this is your volume expansion. For bulk, solids, or liquids, experimental results show that blah, blah, blah. Delta V over V naught is proportional to delta T. Sama macam tadi juga. Except now that the constant is called beta. Just now it was alpha, gamma, now it's beta. Beta is equal to 3 alpha. Saya dah bagi tahu spoiler dah. So beta is equal to 3 alpha. Tak payah tengok movie dia, saya dah kasih spoiler dah. Okay, so again you can expand this. You can do this on your own free time. Basically you will get V equals to V naught dalam kurungan 1 plus beta delta T, where beta is equal to 3 alpha. The change in volume, this is your first equation for volume. The second equation is this guy. Okay, equals to beta delta T. This is naught, V naught. So now let's do a little recap on what we have learned so far about heat. Insert new slide. Saya bila saya mengajar mesti saya jadi blur sekejap. How do I insert? Okay, this one, new slide. Okay, so kita dah belajar pasal thermal expansion and thermal equilibrium. What is thermal equilibrium? It is when you have the same temperature, right? And kita belajar pasal zeroth law of thermodynamics. Okay, which is if A is in equilibrium with B, dia berkawan bersama-sama. And if B is in equilibrium with C, which means that A and C is also in equilibrium, or whatever the case that you might find. Doesn't have to be A, B, C. It can be your friend, yourself, and another person. Doesn't matter. You know what this means. Thermal equilibrium. And then we talked about the measuring devices. And then second is thermal expansion. Okay, so we have length, we have area, we have volume. Okay, so length, belajar delta L over L naught equals to alpha delta T. This guy, it's pretty easy. Gamma, 3 beta, gamma delta T. And then this guy is V over V naught, beta delta T. And you have a bunch of equations. L equals to L naught 1 plus alpha delta T. And sama juga A naught 1 plus gamma delta T. V is V naught 1 plus beta delta t. Okay, so alpha is alpha, gamma is 2 alpha, beta is 3 alpha. Okay, let's have our break. If you have any questions, you can ask me now. Let's come back 12:10 p.m. Come back. If you have any questions, you can ask me now. Okay. Otherwise, you are free to rest. Lepas ni kita nak buat exercise. Make sure you come back. Don't disappear. No questions for me? Am I muting? Oh no, tak mute pun. Oh, susah ya. 37. Who is missing?
Doctor.
Yep.
I got confused with the volume expansion formula.
Volume expansion formula. Kejap.
I mean, for the new volume, not mistaken, the next
This
slide.
one?
Volume of the object. I got confused with this.
Because?
Because the V is equal to AL, right? Then
If I picit abang macam semalam, cepat. Alah. Tadi dah goreng telur. Dah goreng telur tadi.
apakah?
Siapa yang goreng telur tu?
Astagfirullahaladzim.
Lantai cap.
Sekejap.
Sorry, ampun.
Tak apa, tak apa.
Nak telur juga cap.
Icap.
Lapor cap, lapor.
Ya Allah.
Sorry.
Okay, kenapa dengan volume tu?
Yang A0 dengan L0 tu dia hilang terus kan macam mana, Doktor?
Okay. Mana-mana saya punya pen. Okay, so kita tahu volume is area times the height, right? So this is area times L. When you times area with L, you get volume. So when A0 times L0, this gives you V0. Okay, so far everyone okay with that? A0 times L0 is V0. Okay, and then kita tahu alpha that is squared becomes super small. So we are going to abandon this because the value is really small. So you can basically ignore. Remove pen, kenapa? Okay. So now you are left with V0 times 1 plus 3 alpha delta T. Faham tak? Faham tak kenapa V0 tu?
Faham, Doktor.
Okay.
Thank you, Doktor.
Welcome. Okay, let's dah pukul 12.10 ke? Okay, dah. So kita dah recap. So this is the coefficient of expansion. Am I recording? Yes. Am I muted? No. Okay. So here we can see that aluminum has 24 times 10 to the minus C. This is your alpha. Average coefficient of linear expansion. Your alpha is over just degrees Celsius. Oh, kejap. Okay, sorry about that. Okay, so your alpha is over degrees Celsius, which means that your equation, your delta T, if this guy is over 1 degree Celsius, your delta T should be in Celsius. Kenapa Celsius saya macam tu? Let me use a different color because this is like confusing. 1 over Celsius is the unit for your alpha, which means that this guy has to be degrees Celsius. It's not Kelvin, it's not Fahrenheit, it is in Celsius. If they give you something that is in Kelvin, you need to convert it to Celsius first. But that jaranglah berlaku, selalunya kasih in Celsius. So your alpha is in degrees Celsius. This is your linear expansion. If they are asking you about area, 2 times alpha, which means that this guy times 2 gives you gamma. And if you are talking about volume, like a block of aluminum, times this by 3 to give your beta, okay? So most of the time, they will give you alpha only. So you need to keep that in mind. So this is gas and, gas and liquid. This guy is a gas, air is gas, gasoline is liquid. So liquid and gas, semua volume expansion, semua in beta. So this is already 3 alpha. Tak payah buat apa-apa dah. They already give you the volume expansion. This is already 3 alpha or beta. So just use it as it is. Why am I telling you about this table? Because in your question, they will give you alpha only. You need to know when to use 2 alpha, when to use 3 alpha, and so on. Your coefficient will always be in degrees Celsius, which means that your change in temperature should be converted to Celsius if it's not already in Celsius. Okay. Now let's do an example. Terkasih pula kejap Stop sharing. Kejap saya nak share this one. Oh ni senang je. Sekejap dia soalan lain tak? Okay. Okay, let's go over an example first and then we will do an exercise. I hope everyone is back here. Tak hilang. How do I share this? Sharing. Okay, so here the question says an aluminum rod of 50 centimeter long, right? At 10 degrees Celsius. So this is your T naught. This is your L naught. Kenapa? But this is the original condition. What is its length? Maksudnya, what is its new length at a temperature of 120 degrees Celsius? So this is T. So change in T is equal to T minus T naught. So 120 minus 10 is your delta T. The coefficient of linear expansion for aluminum is 22 times 10 to the minus 6. This is your alpha. This is your alpha. 50 centimeter is your L naught. Do I need to convert this to meter? Do I need to? Can I use it as it
No.
is?
Oh.
Why do I not need to convert it to meter?
Because the question didn't ask so.
Okay, betul. Thank you. But okay, the real reason when you have to convert something or when you don't have to convert something is related to your coefficient in the equation. In this equation, the coefficient is only it only cares about degrees Celsius. So itu je yang awak kena convert. Benda lain dia tak kisah. So you can use it as it is lah. Okay, so here they only care to have the temperature in degrees Celsius. So itu sahaja yang awak kena convert. If you use L naught as centimeter, you will get centimeter. If you use your L naught in millimeter, you will get your answer in millimeter. Sama juga pakai meter, dapat meter. Okay, kalau diminta in meters, then convert to meter. But your equation, dia tak pilih kasih lah, dia terima semua jenis length. Okay. Moving on, example 14.2. At 15 degrees Celsius, the surface area, so we are talking about area here, A naught is 550 centimeters squared. That is your information. This guy is your T naught. So T naught is 15 degrees Celsius. Find the change in the lead sheet surface area. Change is this guy, delta A. B, the new surface area of the lead sheet. So it's asking you about A. If it is heated to 100 degrees Celsius, so this is your T. Your delta T is T minus T naught. So this is 100 minus 15, which is 85 degrees Celsius. Okay. So just use the equation. They want to find the change. So use this equation, delta A over A naught, gamma delta T. The coefficient of linear expansion is, this is your alpha. Again, it did not give you gamma. So you have to convert it to gamma. So 2 alpha. Okay, so delta A is equal to 2 alpha. A naught dibawa ke sini. So dapat 2 alpha A naught delta T. So alpha is this guy. So this is your alpha times 2. This is your area. This is your delta T. A naught. So you will get your delta A over here. Delta A is equal to A minus A naught. You know what your A naught is, so you can find out what your A is over here. Delta A is A minus A naught, so you can find out what A is. Delta A, you solve for delta A, you got 271 Your A naught is 550 centimeter squared. Kalau you use this guy as centimeter squared, your answer will be in centimeter squared. So tak payah convert apa-apa, just tambah. Make sure the both units are the same before you add them together. This is your final answer, your new area. So they expand by 2.71. The final area is 552.71. Senang je, pakai equation je. So let's do an example. Let's do an exercise. Ada dua kat sini. I've given you the answer. I will call someone out to help me to buat jalan kerja lah. Okay, so I'm going to give you 10 minutes to 12 lah. 12 minutes for both questions. And I will call out my lucky winner as usual. So please do your best. If you don't know, you can ask your friends, you can ask me, doesn't matter. Okay, 12 minutes. Sekarang pukul 12:18. Let's finish by tambah 12 berapa? 12:30. Okay, so that is when I'm going to call out someone to help me. Please try it. Senang je. Any questions for me? Okay, 8 minutes to go. I'm assuming exercise 14.1 dah settle. Panggil siapa? Oops, tertutup pula. Sorry. Didn't tengok participants. Can I get Redo to do the first one? Redo, are you still there?
Yes, Doktor.
Okay, nombor 1 boleh? Senang je.
Okay.
Okay. Dah ready ke ataupun perlukan masa lagi?
Lagi sikit.
Okay. And the second one, since we have 8 more minutes, wait, how many? 7 more minutes. Siapa I ask Aisha. Is Aisha there? Yeah. Okay, Aisha nombor A, 14.2A. And Shakira, B. Shakira ada?
Ada Doktor.
Okay. Boleh Kalau salah tak apa, kita akan buat sama-sama. But please try your best first. Oopsie. Duplicate slide. Redo dah siap ke Redo? Belum lagi? Ouch. Orang lain dapat tak jawapan dia? Boleh dapat Okay, 5 more minutes. Oops. Redha dah siap ke Redha?
Dah.
Okay, let's do yours first. Sementara kita tunggu siapa tadi? Aisyah dengan Shakira. Sekejap close this one. Susah tak Redha? Senang je kan? Redha, hilang dah.
Ada keliru sikit tadi.
Oh, keliru. Okay. So, okay, what is your first step? Cerita kat saya tulis.
Saya guna formula nak kira ni nak kira increase in volume, saya guna delta V
Delta V, okay,
equals to beta V
equals to
beta V.
beta V
Beta V delta T.
delta T. Okay. Lepas tu,
Next step yang beta V tu jadi 3 alpha.
beta V equals to 3 alpha. Awak cakap beta V ni macam ni ke?
Ya saya. 3 alpha V.
Oh, 3 alpha V, okay. Alright,
3 alpha V delta T.
okay. Okay. Delta T. Okay, betul? Lepas tu?
Lepas tu saya masukkan nilai semua 1/100. Yang 1% tu saya jadikan 1/100
Okay.
equals to 3
3.
dan dalam kurungan 22 darab 10 kuasa negatif 6. Sekejap kita tengok balik. Lepas tu delta T.
Okay, delta T awak apa?
Nak cari delta T.
Okay. Lepas tu, saja test awak. Okay, lepas tu?
Lepas tu saya kira yang 3 darab dengan 22 saya dapat 0.00066 T.
Okay. Lepas tu?
Lepas tu
Delta T
saya
awak berapa?
delta T saya 151.5.
What is the unit here?
Tak ingat pula sekejap. Degree Celsius.
Degree Celsius. Okay. What is temperature change required to produce the 1%? Okay. Kenapa awak decide 1/100 ni?
Sebab 1% saya jadikan 1/100 lah.
Okay. So, yang ni persen. What is delta V? So 1% is equal to 1/100. Delta V is jawab awak betul. Cuma saya nak tahu kefahaman awak tentang delta V. Jawapan awak betul Redha. Betul. Thank you.
Sebab delta V tu increase in the volume. So saya gunalah 1% tu which is 1/100.
So, okay. Okay. Contoh tadi kita cakap pasal change in let surface sheet area was A. Yang ni dalam sentimeter cube. Sentimeter square, right? Kat sini awak kasih saya benda yang tak ada unit. What is the change in volume? Betul tak? Faham tak apa yang saya tanya ni? Okay, tadi delta A is centimeter cube. Delta V centimeter squared. Delta V should be something in, kat sini meter cube lah.
Meter cube.
Okay. 1% is equal to 1/100 is correct. Betul. Mana pergi awak punya meter cube?
Allah. Saya lupa letak.
Tak.
Kita tak, bukan. Aduh Saya confused.
Okay, saya cerita Okay, delta V
Okay,
awak
boleh.
is the change, right? Sorry. Delta V is equal to V new. Okay, thank you Reda. Saya cerita tolak V naught. Dia akan jadi a change in 1%, right? So 1% ni Reda cakap is 1/100. Yang ni ialah 1%. Tapi 1% ni 1% of apa? Kat sini untuk mendapatkan increase in 1%, kita kena buat 1.01 V naught minus 1 V naught. Baru kita akan dapat 0.01% of V naught. Faham tak? Saya nak cerita pun saya takut orang lagi confused. Okay, betul lah Reda buat tu betul. Tapi kat sini dia tertinggal 1. Kalau benda ni bukan 1, kalau benda ni let's say 27, 1/100 ni salah. Tapi disebabkan dia bernilai 1, 1/100 ni betul. Okay, kita tukar, kita flip sikit soalan dia. Okay, thank you Reda, betul lah. Awak punya jalan kerja betul, thank you. Okay, nak tak dapat pula. Dah jadi susah kan soalan ni tiba-tiba. Okay, so let's say dia cakap 1% increase. 1% increase. Let's say awak punya volume, initial volume ni soalan untuk semua orang bukan untuk Reda je. Let's say awak punya initial volume is nombor yang pelik-pelik sikit lah, 36 meter cube. Saya cakap, okay, what is if the cube expands by 1%? If the cube expands by 1%, what is the new volume? If expands by 1%. Okay. Now, original volume kita adalah 100%. Kalau dia expand by 1%, volume dia akan menjadi 101%. Okay. So kalau 100% equal to 36 meter cube, apakah value V new ataupun apakah 101%? So 101% over 100 darab dengan V naught lah. Sebab kita nak cari 1% increase tu kan, the new V. So this is V over V naught. Yang ni kita buat cloud lah. Ni hint je tau, ni bukan value. Okay, so 101 over 100 times 36 is what? Divided by 100.
36.36.
36.36. Thank you Haikal. Haikal kan tadi kan? 36.36. So this is your V new. Okay. Pertambahan yang berlaku kat sini adalah sebanyak 0.36 meter cube. Betul tak? Semua orang faham tak setakat ni?
Faham.
Okay, faham Pertambahan yang berlaku adalah 0.36 meter cube. Okay. Pertambahan V, the change in V is 0.36 meter cube. Dan pertambahan ini bersamaan dengan 1%. Okay. Sekarang ni benda Allah ni ada meter cube. Tapi jawapan Reda tak ada meter cube sebab dia tak darab dengan 1 meter cube kat sini. Jawapan dia betul dah. Okay. So, boleh tak saya nak dapat benda yang sama kalau saya tak pakai 101 bahagi 100 ni? Boleh. Saya buat macam ni je. 1 over 100 darab 36. Okay, dapat berapa? Dapat 0.36. Saya rasa lah. Betul kan? Bagi, betul. Dapat 0.36 which is the same. Saya pakai 101 bahagi 100. 101 adalah V. 1% adalah delta V. 101 adalah V. 1% adalah delta V. Apa yang Reda buat ialah dia buat 1/100 je. Dia tunjuk kat saya peratusan je. Peratusan of apa? Tak tahu. So kat sini Reda kena tambah 1 meter cube untuk menjadikan equation ni lengkap. Tapi disebabkan saya tengok jawapan akhir je, dah betul dah lah, dah full mark dah lah. Kalau V awak bukan 1, salah This is benda ni okay sebab dia 1 meter cube lah. Faham tak? Ada tak orang yang confused? Should I repeat myself? Is everyone okay?
Yes.
Okay.
Ada tak orang confused? Ada tak yang confused? Kalau saya nak saya repeat, saya boleh repeat dah. Okay? Right, so tak ada Okay, moving on. Aisyah dengan Shakira. Next one. Okay, buang. Okay. Padam dulu, sekarang pukul berapa? Okay, belum lagi. Okay, tadi saya suruh Shakira dulu ke Aisyah dulu untuk A?
Aisyah.
Okay, Aisyah. Can you tell me what is your step?
So first, saya cari delta T untuk changing temperature. So 55 T new minus 50 old. So 55 minus 25.
Okay.
Dia akan jadi 30 degree Celsius. Then saya cari volume initial.
Volume initial, V0, okay.
V0 10 kali 7 kali 5.
Okay.
Saya dapat 350 cm cube.
360 kan? cm cube.
50.
50.
350.
Okay. Sekejap Okay, 350 cm cube, okay.
Lepas tu saya guna formula delta V
Delta V
equals to beta V0
equals to
beta
delta
V is beta B.
Oh, beta. Okay. Saya confused. Okay, beta V0
V0 delta T.
delta T. Okay.
Untuk beta tu saya kali 3 kali 11 kali 10 negatif 6.
Okay.
Dalam bracket 11 degree Celsius negatif 1. Then saya kali dengan volume initial 350 cm cube dengan delta T 30 degree Celsius.
Okay, this is
Saya dapat jawapan 0.35 cm cube.
okay. Thank you. Did everyone get the same step?
Yes.
Okay.
Yes.
Okay, moving on. Shakira, B.
Yang B dia nak new volume. Jadi buat samaan delta V sama dengan V tolak dengan V0.
Okay.
Lepas tu V tu volume dia dapat volume dia kita nak V. So V tu sama dengan delta V tambah dengan V0.
V0, okay. So delta V
So,
0.35.
delta V dia 0.35 tambah dengan V dia yang V0 dia 350.
Okay. So final dia 350.35. What is the unit?
Centimeter cube.
Okay. Alright. Thank you, Shakira. Okay. I hope everyone got that. Senang je, pakai equation je. Yang confusing sikit tu dekat yang soalan yang Reda buat tu So please remember to, kalau tanya pasal percentage, percentage of what? Jangan pakai percentage terus Okay. Nanti, okay. So kita nak move on to heat transfer mechanism. What time is it? Lagi 20 minutes, okay. Bear with me, please. Heat transfer mechanism. New subtopic. So the learning outcome for this subtopic is you have to know how to describe thermal transfer mechanism, which is conduction, convection, and radiation. And then you have to solve problems related to heat conduction and radiation. Okay, so heat transfer mechanism ada 3, conduction, convection, and radiation. Benda yang bersentuh, conduction. Kalau ada movement of air, typically it's convection. Movement of liquid, movement of air, typically it's convection. Radiation is when there's no medium in between. Nanti kita akan discover what is that. So in this case, I am heating a kettle. I am heating a kettle. I am heating a pot of water. And it's not touching the stove, dia tak touching. When there's no touching involved, when there's no physical contact, and there is no airflow that transfers the heat, it means that you are heating the pot by radiation, which is rare case lah. But I'm just telling you, conduction kena ada physical contact dan bersentuh. Convection is related to flow, and radiation kita akan discover more. Okay, so conduction, heat transfer that does not involve the motion of molecules of medium over large distances. Okay, apa yang maksud kat sini is it does not have to involve movement lah, movement yang kita nampak. Macam mana saya cerita? Movement ni related to convection kan? Okay, just keep that in mind first. So conduction is a heat transfer mechanism that does not involve any motion of molecules. Maksudnya, kalau dia dekat sini, dia dekat situ jugalah. Dia tak bergerak. Heat is transferred between molecules, atoms or electrons via collision. Dia berlangkah-langkah. Tadi kan kita belajar pasal, just now we talked about heat transfer when an object absorbs heat, dia menari-nari dalam tu, it expands, right? So, yang menari-nari tu is called collision. It's called collision or vibration. Dia akan collide sesama mereka, collide among themselves. And when they collide, they transfer the energy. So tadi memula kat sini je yang kena panas. Lepas tu dia menari-nari ataupun collide with his friends. His friends also gets the energy. His friends collide with other friends and it creates a chain reaction lah. So it started from me, saya langgar awak langgar kawan awak langgar orang lain, and the heat is distributed. What is distributed here per se? Heat energy ataupun kinetic energy, because they are vibrating or they are colliding. Kinetic is something that is related to movement, right? So they are actually transferring kinetic energy. They are transferring heat, tapi dia jadi kinetic energy. So okay lah, tak apalah, kita cakap pasal heat energy dulu. So they are transferring heat to each other, but they are not moving. They are just menari-nari kat situ je lah, setempat. Pelik lah, tapi dah dia macam tu kan, dia menari setempat sahaja. So heat is transferred, blah blah. Increase in vibration can be viewed as increasing temperature. So the more rigorous the dancing is, the more rigorous it collides with each other. It means that you have more heat, your temperature also increases. So solids are good conductors and are better conductors compared to gases and liquid. Kenapa? As I mentioned before, conduction dia kena bersentuh. Kalau gas dengan liquid, let's say this is a gas, the particles are not exactly packed together, which means that if they want to collide, they have to travel, right? Compared to an iron block, all the atoms are squished together. So kalau orang nak menari setempat pun, orang sebelah terkena, right? So ni saya, siapa lagi? Ni Sofara. Sofara ke Sofaya? Forgot nama awak. Sofaya. Betul tak? Betul tak? Sofara. Sorry. Okay, thank you. Sofara. Betul tak? Okay, Sofara, this is me. This is Sofia. Kita orang jauh-jauh. So kalau saya menari setempat pun, Sofara dengan Sofia tak terkesan. Dia macam, benda cikgu aku buat ni. Kan? Macam, what are you doing? Macam itulah. But if I am next to Sofia, like this, macam bahu ke bahu, and Sophia is bahu ke bahu with Sofara. When I am dancing at my place, Sophia and Sofara also feels what I'm doing. And they are like, stop it, dude. Gitu kan? So conduction is better when the atoms are close together, which means that solids are better conductors. Okay. Okay, so conduction example. The molecules vibrate about their equilibrium position, menari setempat. Particles near the stove vibrate with larger amplitudes. Tadi kan kita ada gambar, okay, kita ada gambar ni kan. So let's say kita panaskan pot tu dekat sini, ni bawah pot tu. Buruknya. Okay, so anggaplah kat sini adalah that one particle of molecule yang dipanaskan oleh stove. Atas ni dia tak panas, right? Macam mana particle ni nak transfer to this guy so that everyone becomes hot and boleh panaskan makanan dalam pot. So dia akan menari setempat, dia akan kacau orang sebelah dia akan kacau orang sebelah dia, and so on sampai berjumpa yang hujung sekali. So everyone now is hot or menari setempat. So that is how conduction happens. You start from one point, chain reaction goes further and further and further. Okay, so conduction, okay. The slab allows energy to transfer from region of higher temperature to region of lower temperature. We talked about thermal equilibrium just now. When we have two objects that are not, which do not have the same temperature, when they are in contact with each other, there will be heat transfer. The heat transfer occurs from the high temperature to the low temperature. Ini macam common sense lah. Yang panas, heat akan transfer heat to yang sejuk. Kalau saya sejuk, saya pegang benda panas, tangan saya jadi panas. So heat transfer happens. Okay, so warmer body, heat flows to the cooler body. So the heat transfer rate can be described by this equation. What is this equation? Q means heat energy. So heat energy is in joules, right? Joules, because it's type of energy. Kita dah belajar energy last semester sampai dah muak, tapi kena belajar lagi sem ni. So energy is always in joules, right? So heat energy is a type, heat is a type of energy and it is in joules. Let me write that properly. Nak kecil sikit lah. Boleh tuliskan ni, tak ada. Dia tak tulis kat sini. Let me write it here. Q is heat energy. T is time. What is joules over second? Anyone? Does anyone still remember what joules over second means? I mean, not mean. What is the other unit for joules over second? Energy or the rate of energy?
Power.
Power, yes. Thank you, Amirul Haziq. Panggil Amirul ke Haziq? Forgot.
Haziq.
Haziq. Okay, thank you, Haziq. Joule over second gives you power. So the heat transfer rate is actually power lah. So power. Power is equal to Q over T. This equation is K times A. What is K? K is thermal conductivity. Dia macam alpha juga, tapi dia K. It's a constant that depends on the type of material. A is your cross-sectional area. It should be in meter squared. Your time is in, what is your K in? Think balik. K is in, this is your K. Watt, joules per second over meters per Celsius. Okay, meter per Celsius. If your K is in watt over meter per Celsius, this means that your temperature should be in Celsius and your A should be in meter lah, meter squared. Your L should also be in meter. Okay, so let me write it here, meter. This is in degrees Celsius. This is in degrees Celsius. Okay, boleh padam. Okay. So Q over T is K, thermal conductivity times area times the change in temperature. Sama je. over L. What is L? L is the length of the slab. Okay. K depends on the material that you use. A, what is A? This is your cross-sectional area. So apa yang berlaku kat sini, dia nak tahu what is the Q that travels through a cross-sectional area. What is the rate of Q that travels through a cross-sectional area? Okay, so that is conduction. This is conduction problem on this in exam is very common. Just throwing it out there for you guys. Okay, so this is thermal conductivity. So metal, in general, kita tahu metal has a higher thermal conductivity, right? So aluminum is 240, gold is 314, and then steel 14. Oh, okay, so steel is not a good thermal conductor. Asbestos, concrete is not a good thermal conductor compared to aluminum lah and gold. And then air is even poorer thermal conductor. Kalau stove kat sana panas, sebabkan air ni thermal conductor yang bagus, saya terus rasa alamak panasnya. So tak boleh panaskan apa-apa. Bahaya kan? So air needs to be a poor thermal conductor. If not, we will die. Okay. Okay, moving on. So kat sini kita kena tahu K is watt, which is power, over meter per Celsius. You don't have to memorize. I'm just, you need to be aware of the units used so that you will use it correctly in your equation. Okay, tu je yang kena tahu. Okay, so conduction with multiple materials. I told you K is related to the material. What happens when we have two types of material? Let's say this is gold, AU, and this is copper, CU, I think. So this is gold and this is copper. So they have different Ks. So AU has K1, CU is K2. But because the heat transfer is in series ni maksudnya, series apa cakap? Kalau parallel selari, series
Bersiri.
bersiri. Okay, what does bersiri mean? Kita anggap dia bersentuh lah, bersentuh. Bersiri, bersentuh. Okay, sebab saya tak tahu nak describe bersiri ni macam mana. Thank you, Haikal. So kat sini dia bersentuh, maksudnya the source panas dengan source sejuk dia daripada orang yang sama. Memang lah. Okay, abaikan. So dia bersentuh lah. Okay, we have two materials. This is our hot source. This is our cold source. So the heat transfer or the rate of heat transfer is Q1 over T1. This is related to K1 equal to Q2 over T2. This is related to K2. Okay, remember Q over T is equal to Ka delta T over L. Q1 kat sini, which means that Q1, T1, K1. A kat sini sama, the A dia tak berubah, so kita akan anggap sama. TH minus TC sama, L ni depends on here. L1, this is L1. And then we have Q2 over T2 equals to K2A delta T. A and delta T are the same. L2 can be different. L2 depends on the length of the material. Now, kita cakap sini Q1 over T1 equals to Q2 over T2. And then awak boleh equate these two equations together. L1 over K2, what is that? A delta T over L2. Now, because A and delta T are the same, kita boleh cross out. Let me cross it out. A tak cross out pula. Okay, delta T sama. Okay, so you are left with K1 over L1, K2 over L2 to solve it. Oh, sorry. Saya silap. I am wrong here. Sorry. Let's rewind. Oh my god, saya tersilap. Delta T tak sama kat sini. Sebab apa? Okay. Padam balik. Okay. Saya forgot. Delta T kat sini, this is TH minus TA. This guy is TA. Forgot. Okay, and then this guy is TA minus TC. Okay, kenapa? Kat sini TH material ni, let's say this is material number 1, this is material number 2. Sorry saya kena rewind. Material number 1, the hot source is TH. The cool source is over here. So your delta T is TH minus TA. Patutlah saya rasa pelik tadi. Okay, so TH minus TA. Whereas this guy, the delta T, what is your T hot? T hot is over here. This is your cool. So TA minus TC. Okay, now we can write the equation. Okay, let's write that down. Okay, so Q1 over T1 is equal to K1A. A sama, okay, ni confirm. A sama. Delta T, which is TH minus TA over L1. Yang sama kat sini A sahaja. Okay, if they are in series. And then Q2 over T2 is equal to K2A TA, because TA is at higher temperature than TC, so dia dululah minus TC over L2. Okay, is everyone okay with me so far? Is everyone okay with this?
Yes.
Okay, sorry tadi I'm really sorry, I forgot about TA. Okay, so TA, why is it important to know what TA is? TA ni adalah temperature in between those two material. It is the temperature at the junction. So sometimes they want to know, okay, what is the temperature at the junction between these two materials? Untuk engineering problems selalunya diorang nak tahulah. Okay, so that is why calculating TA is important. Okay. So this is what we got so far, right? Kita boleh cancel out A, should be. Okay, so this cancels out. So L ni dibawa ke atas. No. L ni dibawa ke sana. L1 ni dibawa ke sana. Okay. So L1 dibawa ke sana sebab this is dekat bawah, dibawa ke atas sini, and then L2 ke sini. So you are left with, kenapa dia patah balik semua? Sekejap, abaikan. Dia rearrange lah basically. Okay, so L2 dengan K2 dibawa pergi sini. Tak tahu kenapa. I would prefer to use this equation as it is. Okay, as long as you know how to use it, rearrange lah macam mana pun, jawapan dia akan sama. So TA, dia rearrange lagi. So TA will give you L2 over K2, TH plus L1 over K1, TC over this. You don't have to use this final form. You can use it as it is and solve for TA. Boleh juga. Okay, dia just rearrange. Okay, so we were talking about if conduction happens between two materials. Heat transfer happens between two material, material 1 and material 2. What if we have another material, material 3? How does the equation look like? So now kita nak equatekan ni pun macam susah kan? So kita kena go to this equation and where is it? It's Q over T equals to A TH minus TC. This is hot minus cold over L1 over K1 plus L2 over K2. If you have another material, tambah kat sini. If you have a fourth material, L4 over K4. If you have a fifth material, L5 over K5, and so on. So this is the equation to use if you have two. If you have more, tambah ke bawah ni. L, blah, 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 K, blah, blah, blah. This top part is like this. Okay, so let's figure out which equation is the best one to memorize if you need to. Okay, this guy for sure kena ingat in series Q1 over T1 is equal to Q2 over T2. Wajib ingat, ni memang no compromise. Second one, this one is good if you want to equate, you only have two materials. This is a great equation to use. Okay, you can solve for TA using this equation. If you have three material, this is your second equation. If you have three material, use this equation to find out what is the heat transfer. if you have 2 or more. Okay, so ada 3 equation untuk conduction for series. Is there a way to make this simple? Sekejap Saya tak fikir pula nak cara nak simplekan dia. Let me see. So far saya tak nampak lagi cara nak simple dia. If I figure it out, I'll tell you. But for now, please remember those 3 equations. Okay, so we talked about conduction of multiple materials in series. What about, what time is it? Oh, it's already over 4. Okay, so we are going to stop here. Do you have any questions for me? Whoopsie. Oh, ini parallel. Belum masuk lagi. Any questions before we end class? Okay, I hope everyone is okay with this class, with today's class. If you have any questions, you can personally WhatsApp me, you can ask in the group. Otherwise, have a great day. Don't forget to have lunch. Take care. Okay, bye-bye. I will share the slides later. Bye, everyone.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Okay, doktor.
Take care.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Welcome.